Hi there, today's Thursday, December 13th, and here's today's warm-up. List some evidence that a chemical change and not a physical change has occurred. If you can't remember what the difference between physical and chemical changes are, make sure you go back to Lesson 1 or check out the textbook pages 17 and 18. Today our learning targets are to be able to use symbols to write out a chemical reaction, especially those reactions that take place when a firework explodes. We're going to be using the periodic table to help us write chemical reaction sentences correctly, so make sure that you have a periodic table out and handy during this lesson. So I like to relate things that are new in class to something that you already know something about. For instance, I'm sure most of you have seen a recipe. For instance, a recipe for baking a cake tells you all the ingredients that go into the cake. You put it in the oven, bake it, and it looks like something completely different comes out. Well, the truth is, the ingredients are still there. They've just been changed in some way. So what we're going to do is write chemical reaction sentences that explain what goes in. These are going to be called the reactants, and what comes out. These will be called the products. So we are going to study this reaction sentence together for a little bit. Now, right now, this probably doesn't mean a whole lot to you. This H2O2 is the chemical formula for hydrogen peroxide. H2O2 is hydrogen peroxide, and most of you are familiar with hydrogen peroxide, something that's commonly used to clean out cuts. Now, you might have noticed that when you do pour hydrogen peroxide on your skin or on a cut, it tends to bubble, and sometimes it stings. That's actually a chemical reaction taking place between the peroxide and some enzymes in your skin. The product of that reaction is water and oxygen gas, which is why it bubbles. So if we were to read this reaction sentence, it would sound something like this. 2 molecules of hydrogen peroxide yields, that's what we say for the arrow, 2 molecules of water and 1 molecule of oxygen. So what we need to learn are some different terms for each of the numbers that we see in this chemical reaction sentence. The big number out front is called the coefficient. The coefficient tells us how many molecules there are. So in a recipe, this would be like 2 eggs. This recipe calls for 2 molecules of hydrogen peroxide. The arrow means yields. This could be a reaction that breaks down something, builds something up, makes elements switch places with one another. In this case, you can see that 1 big molecule gets broken down into 2 smaller molecules. These little numbers down here attached to the element symbols are called subscripts. You might recognize the word subscript from a font in Google Docs. A subscript is just something that's written below. And these are numbers that indicate how many atoms of each element there are. Now, we are not allowed to ever change or alter these numbers in any way. For instance, hydrogen peroxide is always 2 atoms of hydrogen and 2 atoms of oxygen. If I were to take away one of the oxygen atoms here, I'd have water, and this is definitely not water. What we need to do now is to figure out if the elements that went into the reaction, the reactants, are in the same amount as the elements that come out of the reaction, the products. So what we need to do is use math to calculate how many atoms of each element are present before and after the reaction to prove elements were not created or destroyed. And this will show us if the equation is balanced. So we are going to take a look at this equation again. We can see we have the exact same reaction sentence. 2 molecules of hydrogen peroxide yields 2 molecules of water and 1 molecule of oxygen. The left side is always going to be called the reactant side. The right side is always going to be called the product side. So, see if you can figure out how many molecules there are of peroxide and how many molecules there are of water. If you need to pause the video to go back to the other slide, or to rewind to my previous slide, feel free to do that now. We also want to find out how many molecules of oxygen there are. So remember, the number of molecules is going to be the coefficient out front. So how many molecules of peroxide do we have? H2O2 is peroxide. The coefficient of 2 out front tells me I have 2 molecules of peroxide. How many molecules of water do I have? H2O is water. The number out front, 2, tells me I have 2 molecules of water. But what about oxygen? Oxygen doesn't have a number out front. There's nothing here. The only molecule is O2. And remember, this little number doesn't tell us about the number of molecules, only the number of atoms. No number out front is an understood 1. So there's 1 molecule of oxygen. Now the next thing we have to do is use simple multiplication to figure out how many total atoms we have. Now we could write this sentence in a different way. We could write H2O2 plus H2O2, which would be the same as 2H2O2. But this coefficient of 2 out front just makes it easier to write the sentence. Now what if I wanted to know how many total atoms of hydrogen I had? Well, you might want to say, well, there's 2, H2. But remember, we have this coefficient out front, which means it's kind of like writing H2O2 twice. I can do a quick multiplication formula, or in my head, I can just imagine this being written twice. 2 times 2 is 4. There are 4 hydrogen atoms on this side of the equation. Now, according to the law of conservation of mass, there should also be 4 hydrogen atoms on the other side. I have a coefficient of 2 out in front of the molecule for water. 2 times 2 is 4. So I know that this equation is balanced because there are 4 hydrogen atoms on each side. Now let's take a look at oxygen. Again, I can use this coefficient number 2 out in front to multiply it by the subscript for oxygen. 2 times 2 is 4. Now what about this oxygen over here? There isn't any subscript. Just like this coefficient of 1 over here is understood, no subscript is understood to be 1. 2 times 1 is 2, plus 2 more over here equals 4. So I have 4 oxygens on this side, 4 oxygens on this side. So what does that mean? All that means is that the ingredients that went into the formula are the ingredients that come out. When we rearrange atoms into different molecules, the atoms still exist, but because they're in different molecules, they have very different properties from one another. H2O, definitely good for us. If you were to drink peroxide, it wouldn't be so good. So, if you're in class today, you get to see a demonstration of the 3 main types of reactions. The first main type of reaction is a synthesis reaction. The synthesis reaction we're going to do in class today is burning magnesium. The reaction equation is 2 magnesium elements plus oxygen gas, which is always written O2, will yield 2 molecules of MgO, which is magnesium oxide. Synthesis means put together. In this case, magnesium and oxygen get put together for magnesium oxide. The second type of reaction is opposite of synthesis. Decomposition means to break down. And we actually just saw that reaction type in our example. When you pour hydrogen peroxide on your skin, it breaks down into water and oxygen gas. And let's see, this little 2 right here should be a subscript. The third type of reaction is pretty cool. Replacement reactions happen a lot of times with metals that trade places with each other in certain types of reaction. The example we'll see today is a reaction between copper sulfate, which is a blue liquid, and an iron nail. 2 molecules of iron plus 3 molecules of copper sulfate yields 2 iron sulfates and 3 copper. The iron and the copper trade places. Here are the 3 types of chemical reactions in an easy-to-read flowchart: synthesis, replacement, and decomposition.